Swayam Prabha. Digital India. Educated India.
Hello viewers, in the last class about this topic well foundation, we discussed various forces which act on well foundations, and then we discussed that what are the various combination of these forces to be considered while doing the stability analysis of well foundation. Then we saw that the lateral stability of well foundation is an important factor as far as the stability of these type of foundations are concerned, and in that one we studied in detail the method which has been given by Terzaghi, and we took up an example also, and then we started with the method which uses elastic theory, which has been recommended by IRC. So now in that one I am going to proceed in continuation of that in the last class I have already discussed what are the two steps to be followed in the elastic theory method by IRC. Now let us start with the next steps of the analysis. So the step 3 is that you have to check that the point of rotation of well lies at base by ensuring that the frictional force at the base is adequate to restrain the movement of wall. And how it can be done is that you have to see to it that the horizontal force H should be greater than m by r into 1 plus mu prime minus mu times w, and at the same time H should be less than m by r 1 minus mu prime plus mu w, where this r is equal to d by 2 I by m IV, and mu is equal to tan phi is the coefficient of friction between the base of well and the soil. The angle is taken to be equal to phi due to roughness of concrete plug. When I was discussing about the components of well foundation, we saw that there were two plugs, one was top plug, another was bottom plug, and where the concreting was done. So here, because the bottom plug is made up of concrete, so the angle has been taken to be equal to phi because or to take into account the roughness of that bottom concrete plug. So these two conditions together have to be satisfied. Now step 4 is that you have to check that the soil on sides remain elastic. This can be ensured by keeping the slope of pressure parabola at top below the passive pressure line. That is m by I should not be more than gamma Kp minus Ka, where gamma is your unit weight of soil, that is submerged unit weight when it is below water table, then Kp and Ka, they are passive and active earth pressure coefficients respectively. So in step 3 you have to satisfy those two conditions, and in step 4 you have to check that this particular condition is satisfied. Then as you saw that in Terzaghi's analysis, this Kp and Ka, they were evaluated using Rankine's theory. However, in this case this Kp and Ka have to be calculated using Coulomb's earth pressure theory, and which you have to assume in this, because when you use that Coulomb's earth pressure theory you require wall friction etc. also. So here in this case you have to assume that the coefficient of wall friction delta as 2/3 of phi, but limited to 22.5 degrees. So, in case this 2/3 of phi is more than this 22.5, so you have to take this delta to be equal to 22.5 degree. Now, step 5 is that you have to check base pressures, ensuring that the maximum compressive pressure is less than the allowable bearing pressure and the minimum pressure is not tensile. You have seen that in case of Terzaghis analysis also we found out the base pressures in which one was maximum and one was minimum, that is F maximum and F minimum. So, likewise here also you have to do that, and the maximum one should be less than allowable bearing pressure and the minimum one, it should not be tensile. That means how do we check that whether it is tensile or not? In soil mechanics we take this tensile stress to be negative. So, in case if the minimum stress value is coming out to be negative, that means that it is tensile. So, the minimum pressure should be greater than 0. This will imply that that particular pressure is not tensile. So, here sigma 1 and sigma 2, one is maximum and another one is minimum. It can be obtained as W minus mu prime P over A plus minus MB upon 2I, where sigma 1 and sigma 2 are maximum and minimum base pressures respectively. A is area of base of well, P is total horizontal reaction from side, which can be calculated as capital M upon R. B is width of base of well in the plane of bending. So, if the conditions in step 3, 4 and 5 they are not satisfied, then well shall be redesigned. That means that you have to take the dimension of well foundation again and provide the checks which have been given in these steps 3, 4 and 5 again. So, the well has to be redesigned. So, for a proper design of the well foundation, all the things or all the condition in all these steps has to be satisfied. Now, we will take an example and let us try to get a feel that how we can deal with the stability analysis as far as a practical problem is concerned. So, in this example, some of the data has been given. Let us try to see that what are these data and how these can be used in the lateral stability analysis of well foundation using IRC method, and into that we had two methods. So, here we will be employing elastic theory method. The following data refers to a well foundation for a single line railway bridge. First thing is given as net downward load on well including self weight is 1400 tonnes. Then horizontal force at scour level has been given to be 200 tonnes. Moment at scour level is 4150 ton meter. Depth of well below scour level is 15 meter. Then saturated unit weight of sand is 2 ton per meter cube. Angle of shear resistance of subsoil is 35 degree. Then angle of wall friction is given to be 20 degree. The external and internal diameter of the well has been given to be 8.5 and 5.5 meter respectively. And allowable bearing pressure is equal to 55 ton per meter square. What it says is that you have to check the lateral stability of well using elastic theory method as per the procedure laid by IRC 45/1972. So, let us try to see that how you can proceed as far as the solution of this problem is concerned. So, first we will find out, as I told you, that projected width of well is equal to some shape factor multiplied by the dimension of the well. So, in case of the circular well, that shape factor was recommended as 0.9. So, in this case this projected width of well will be equal to 0.9 times B, where B is given to be, you can see here it is the external diameter of the well, which is 8.5. So, this L will, that is which is projected length of width of well, will be equal to 0.9 times 8.5, and that is equal to 7.65 meter. Then these geometrical properties we need to find out, as I discussed with you in the last class in the step 2 of this IRC method, that is elastic theory method. So, IB is pi d to the power 4 64, and this will become pi 8.5 to the power 4 divided by 64, and this will result as 256.24 meter to the power 4. Then another geometrical property, which is IV, is LD cube upon 12. It is equal to D is your depth of embedment, which is given to be 15 meter. So, it will be 7.65 L you have already obtained here. So, this is 7.65 into 15 cube by 12, and this will be 2151.56 meter to the power 4. Then using these two geometrical properties IB and IV, we can find, using this particular expression, I is equal to IB plus MIV into 1 plus 2 mu prime into alpha. Then assuming this M to be equal to M, which is defined as KH upon KV, as we have already discussed in step 2, let us assume a value of unity to this particular parameter 1. Then mu prime is defined as tan delta. Delta is given in this problem as 20 degree. So, tan 20 degree will become equal to 0.364. Then alpha is defined as d upon pi d, which is equal to 8.5 upon pi into 15, and this will result into a value of 0.18. Therefore, if you substitute all these values here in this particular expression, you will get I to be equal to 2690.33 meter to the power 4. Now, once this I is known to you, to ensure those conditions on H which we have already discussed in step 3, we need to find out this parameter R, which is defined as d by 2 into I by MIV. We know the value of d, we have found out the value of I, we have assumed the value of M, and we have found out the value of IV. So, if you substitute these appropriate values in this particular expression, you will be getting a numerical value of R as 9.38 meter. Now, as I told you in step 3, you have to ensure this condition, that is H has to be greater than M by R 1 plus mu prime by mu minus mu W. So, for this I am going to first tell you that how you have calculated this value, and then the value of H has already been given to you. So, then you can provide a check. So, first I take M by R 1 plus mu prime minus mu W, and this value is equal to, M value is given to you as 4150, and then R you have just now calculated as 9.38, then 1 plus mu is tan of phi, which is equal to 35 degree, then mu prime is tan of delta, which is tan of 20 degree, minus this mu tan 35 into W, which is given to be 1400, and this works out to be minus 425.09. So, you see this condition that this particular quantity has to be greater than H. So, since it is coming out to be negative, obviously it is more than that H value. So, therefore, this condition in step 3 has been satisfied. So, therefore, we write as hence it is safe. Now, in the step 4 I told you that you need to check that the soil is in elastic state, and what is the expression for that is M into capital M by I should not be more than gamma prime Kp minus Ka. Now, if I substitute the numerical value on both sides of this particular expression, what I will get as M is, we have assumed to be 1, Then capital M is given to be 4150 divided by this I we have calculated at 2690.33 meter to the power 4, and this particular value should not be greater than this gamma prime. Gamma prime is submerged unit weight. So saturated unit weight of the sand is given to be 2, and if you consider the unit weight of water to be 1 ton per meter cube, so submerged unit weight gamma prime will become equal to 2 minus 1, which is 1 ton per meter cube. So that is what here we have taken. Then corresponding to this phi to be equal to 35 degree, using Coulomb's theory, the value of Kp and Ka can be obtained, which have been written like this here. So this value worked out to be 1.54 and this value worked out to be 7.29. So we can see that the numerical values in this particular problem, they are satisfying this particular condition, that is 1.54 is not more than 7.29, and therefore you can say that this condition is also satisfied, so it is safe. Then when the conditions are satisfied, then we have to see to it the maximum and minimum base pressure. As I told you that the maximum base pressure should be less than allowable bearing pressure and the minimum one should not be tensile. So here I use this particular expression to find out the maximum and minimum base pressures, which is maximum one is sigma 1 and minimum one is sigma 2. So in this expression, if I substitute appropriate values like W is equal to 1400 minus mu prime, we have found out tan delta, that is 0.364 into P is 442.52 divided by area of base of the well, which is pi by 4 into 8.5 square, plus minus 4150 into 8.5 divided by 2 into 2690.33, which we have calculated as the value of I. So we get two values, one is 28.39 ton per meter square and another one is 15.27 ton per meter square. So this allowable bearing pressure has been given to you in this problem as 55 ton per meter square. So the maximum pressure is less than allowable bearing pressure and the minimum one is greater than 0, that means it is not tensile. So this particular problem, whatever is the well foundation things that you have taken, that is whatever is the diameter and force and moment, whatever they are coming on the well foundation, the foundation is safe for those particular values. So this is how for a particular well foundation or any practical problem you can carry out the stability of well foundation. Now we will be starting with a new topic related to this well foundation, very important topic as far as the construction of well foundation is concerned. That is the construction and sinking of a well foundation. Various aspects are related to this. So we will be seeing some of the salient features as far as construction and sinking of a well foundation is concerned. So the first one is that the accurate layout of center line of the bridge and the location of piers and abutments is of paramount importance, because till you have the accurate layout of the bridge as well as various piers and abutments location along that, it will not be possible for you to install or go for construction of a well foundation. So it is very important factor. Now the commonly adopted method for laying out the station point line at right angles to the center line of the bridge on the high bank on one side of the proposed bridge or anywhere between the abutments where level ground may be available. And this particular method is that masonry pillars are constructed on this line to serve as station points for checking the location of piers. You can see here in this particular figure that these are the station points, that is 1, 2, 3, 4, 5, and then these are the various station points for bridge layout. So for each bridge pier, 2 piers are located such that by setting theodolites at each of these pillars at a given inclination to the station point line, the center line of the pier is identified by the point of intersection of the lines of collimation. This statement will be more clear if you look at this particular figure. Now, let us say that this line of collimation is making an angle of 45 with this line which is joining the station point. Then I know this station point and this station point, they are already been located. So, you can use a theodolite and make an angle which is predefined. Let us say here in this case, as it is showing in this figure, is 45. So, you can have a line of collimation at 45 degree from this station point as well as from this station point. So, wherever they will intersect, this will give you one point for laying out the bridge center line. Likewise, you can get various points on this particular line. Now, the second thing is that how you can pitch the well curb. Well curb is the lowermost part of the well foundation. So, it has to be constructed first. So, that thing is pitching the well curb. In this one, there are few salient points which you need to keep in mind, is that if the site of pier is dry, it is easier to pitch the well curb. In case if it is dry, then it becomes easy. However, if the site of the pier is not dry, that is under wet condition, then it becomes little difficult to pitch the well curb. So, the well curb is usually pitched at about 15 centimeter above the low water level. Then excavation should be carried out up to the level at which the well curb is proposed to be pitched, and the center of the well curb should be carefully marked. So, all these points, when you go for the construction and sinking of the well, this is the first thing that you need to do, that is pitching of the well curb, and all these points you need to keep in mind. Then the well curb should then be assembled on wooden blocks or sandbags placed at suitable intervals, so that while assembling the curve it does not sink. Concreting is done after placing the reinforcement. Usually M150 or a richer concrete mix is used in well curb. So, when you go for pitching the well curb, one has to use either one M150 or a richer concrete mix. Now, we were talking of in case the site of the pier is dry. Now, what happens if it is having a standing water? So, in case if the site of pier has standing water to a depth less than about 1 meter, a sand island should be made by laying a few bags of sand, and then the curb is laid on the sand island, because it need some base to rest on. So, that is why in case if the water is there which is having a depth of less than 1 meter, then those sandbags can be used. For greater depth of water at the site, that is, let us say if it is more than 1 meter, the island is generally constructed by driving 2 rings of bully piles and filling the annular space between 2 bully rings by puddle or sandbags. In case if the height of the standing water is more, then only sandbags will not serve the purpose, and in that case you have to drive 2 rings of bully piles, and the space, annular space which is in between these 2 rings, that you have to fill with the sandbags or puddle. Then RCC well curb should be allowed to set at least for a week before sinking is started. So, 1 week time you have to give. Usual recommendation is to sink the well curb alone after curing it before raising the steining above it. You know that the well curb is the lowermost part of the well foundation, and on top of that it is connected to the well steining. So, first the pitching of well curb is takes place, and then it is recommended that the well should be sink only after you have cured the curb alone, and then only you should go for the raising of stemming above that well curb. Now, after the pitching of well curb is over, there comes well stemming. So, let us see that what are the various points that we need to keep in mind while going for construction and sinking of a well foundation. So, well stemming could be of masonry or RCC. Initially, when the well has very small grip length, the chances of tilting are more. I told you that when you have to sink the well, the tilting and the shifting should be as least as possible and they should be within permissible limit. So, when the well has very small grip length, the chances of getting the well tilted or getting the well stemming tilted is quite high. The chances of tilting increase considerably if the well is made top heavy by raising the stemming too high in the first instance. So, you have to keep in mind that in one go you do not raise the vertical well stemming quite high. So, a better approach is to sink the well curb alone without raising any stemming above it. That means, once the sinking of the well curb is over, then only you should start going for well stemming. The stemming, once the well curb has been sunk to that particular desired depth, then only the stemming should be raised in heights of about 1.5 meter at a time after allowing at least 24 hours for setting. So, in one go you should raise till 1.5 meters. Once the well has attained a grip length of about 6 meter or more, the stemming can be raised in installments of about 3 meters, which was earlier as 1.5 meter. Now, when the grip length is more, that is 6 meter or more, then this installment can be higher, like of the order of say 3 meter. Now, to sink the well vertically downwards, it is of paramount importance that the masonry of well is perfectly vertical and in line. So, we need to keep a check that when you go for the construction of well stemming, first thing is that it should not be too high at first instance when the grip length is less, and when the grip length is more than 6 meter or so, then you can go in the installments of 3 meter height of well stemming. Then we have to keep in mind that it should be the masonry or the concreting which are being laid in well stemming, that has to be perfectly vertical and in line. This can be achieved by raising the masonry with the help of straight edges. So, when you raise the stemming with the help of straight edges, the verticality of well stemming can be taken into account. A number of 1.2 to 2 meter long straight edges should be fixed all along the outer periphery of well curb at suitable intervals using clamps, so that at least 0.6 meter length of these straight edges is within the well curb, with the remaining portion projecting above the well curb. See, well curb will be having a plan. Let us say if you are going for circular well, then it will be having a circular shape in plan. So, you have to provide or you have to fix around 1.5 meter to 2 meter straight edges all along the periphery of the well curb, and you have to keep in mind that around 0.6 meter of these stress edges remain inside the well curb and rest all projecting outside. The straight edges need to be refixed at the higher level as the construction of masonry progresses. Let us say that in first go you have fixed 1.5 to 2 meter long straight edges. Now, once the concreting of the well stemming or the masonry construction till that particular height is over, then you have to shift those straight edges so that the construction of well stemming above that height can progress. So, the entire stemming should be raised in this particular manner. To enable fixing of a straight edges in each stage of sinking should be stopped. leaving about 0.6 meter of the staining outside. So, this thing you need to keep in mind, because it is not only the construction as is the sinking also which is taking place simultaneously. The well is sunk by excavating the soil from within the dredge hole. That is, as you process in the ground, what happens is a dredge hole is created and the soil inside that dredge hole is excavated, and then as a consequence the well is sunk. So, excavation and scooping of soil can be done manually or mechanically. A large size spade jam is used for excavation under water. So, it is the matter that how you are taking out the soil from the dredge hole, either manually or mechanically. So, you can see here this gives a pictorial view of a typical jam. Here you have the steel pan. It is connected to a rope is here also, it is sail bullies, then you have a hammering base, and here you have this guide rope. How it works, let us try to see in this particular slide, that the jam tied to a rope moving over a pulley is lowered into the well. Okay, so the blade is pushed into the soil by the driver. When it is lowered to the pulley, it's the blade of that particular jam is pushed into the soil. Then the jam gets full of soil and which is taken out. So, the jam which is full of soil is then pulled out by men and emptied outside. Likewise, the process is continued till the total excavation has been taken place. So, when a clay stratum is to be pierced, rail chisel, they are more effective. What are they? Here is one typical this figure for a rail chisel. It is a rail here, and then a 1 meter of 1 meter thickness, this particular part is there. So, it is lowered, and when it is taken out, it is filled with the soil. You can empty it on the ground surface and then again lower this. Sinking of a well is using jam is a slow process. So, when you use the jam, you know that every time that you have to lower it, then it will get filled with the soil, and then you have to take it out, empty it, and then again lower it. So, that makes it a very slow process. An improved method is to use automatic grabs or a dredger, which can be conveniently operated through steam or diesel winches and cranes. So, these are all the less of manual effort and more of mechanical in nature. So, these enhances the process of sinking of well. You can see here a typical view of Bell's dredger. Here it is in closed position and here it is in open position. Main chain and side chain, they are being shown in this particular figure. So, this is just a schematic diagram of this Bell's dredger. How it works, we will see in this particular points, that Bell's dredger, it consists of rows of teeth of hard steel fitted to prongs. The dredger is lowered in the open position when the teeth point downward and hence bite to the soil. You can see this is being lowered in open position. You can see the teeth over here. So, it just goes into the soil, it bites in the soil. The dredger is then unlashed and pulled upwards. What happens during the pulling? The dredger gets closes and the prongs join to form a bucket which is full of excavated material. You can see here, when you are lowering it down, it is in open position. When you take this out, it becomes in closed position and it takes a form of this bucket. And in this one you have, or it is filled with the excavated material. So, you can take this out and empty this, and then again you can lower this in open position. So, while sinking through clay, another type of dredger is used. Such a dredger consists of a large number of iron bars which are used to form a cage instead of mild steel plates. In Bell's dredger we saw that you were having mild steel plates and the teeth were there, but in this case it has a large number of iron bars which make a kind of cage. As the sinking of well proceeds, the friction on the sides of the well it increases. Now it is not good for the sinking procedure. So how you can overcome this increased friction is that you have to overcome this increased friction as well as you have to accelerate this process of sinking. For this purpose, the well stenning is loaded through a suitable platform with cartilage in the form of sandbags piled upon it. So we increase the load on the well stenning with the help of suitable platform with cartilage. The platform for providing cartilage should be such that it does not obstruct the process of dredging. So the suitable arrangement has to be made so that the dredging as well as sinking it all goes simultaneously. Air and water jets are also useful in reducing the friction on the sides. These jets usually consist of 25 to 50 millimeter diameter GI pipes fitted with a nozzle at one end. So air and water jets, they are also useful when if you have to reduce the friction at the sides, and usually the diameter of GI pipes of 25 to 50 meter, they are used for this particular purpose. Then these jets, they usually fitted on the periphery of the well, they help in loosening the soil and thus reducing the friction. So the water or air jets, they are there, they loose the soil around the well and subsequently reduce the friction. Then dewatering of wells is sometimes done, particularly when there is an obstruction under the cutting edge. So dewatering also helps the process of sinking. The increased effective weight of the sand and blowing of sand into it will help in displacement of obstruction towards dredge hole. So in case if the dewatering of the well is done, it happens that the effective weight of the sand gets increased and the blowing of sand into it, it helps in the displacement of obstruction near the dredge hole. Now this pulsometer pumps which are worked by steam, they are most suitable for dewatering of wells. However, dewatering should not be tried unless the well has got a grip of at least 9 meter in the sand, otherwise there are chances of excessive tilting of well. Then during the process of dewatering, the well should be continuously washed, so that if the excessive tilts or shifts are being done over there, or if they are occurring, so it can be taken into account, or some corrective measure can be taken right at that particular stage. The sinking should be immediately suspended if there is a remarked tendency towards tilting. So in sinking, it is an important thing that the tilting should not be more than permissible limit. So wherever if you see that the tilting is becoming more, you have to stop the sinking. First you have to rectify that tilt and then only proceed for further sinking of well. Then tilts and shifts. Now coming to the tilts and shifts, some of the aspects related to these. The main objective in well sinking is to sink it straight and at the correct position. However, in practice it is not easy to achieve. So adequate precautions are taken to avoid any tilt or shift during sinking. In case any tilt or shift is observed at any stage, proper record should be maintained and measures to rectify the same is taken at that particular instance only. The various useful precautions which are to be taken to avoid tilts and shifts are that the outer surface of well curb and well stenning must be regular and as smooth as possible. So this if it is quite smooth, the tilts and shifts are relatively less. The radius of well curve should be kept about 20 to 40 millimeter larger than the outer radius of well stenning. The well curve thus projects out from the well stenning, and this projection should be equal and uniform on all the sides. Because it is a monolithic and very rigid structure, so we need to take care of these small things at every stage of construction and sinking. Cutting edge should be of uniform thickness and sharpness. Cutting edge is the lowermost edge or the part of your well curve. Then dredging should be done uniformly and on all sides of well. For a twin well, dredging should be done in both dredge holes uniformly. You have seen that in twin well, 2 dredge holes are formed. So the excavation or the sinking for both the dredge holes should be done uniformly. The well is constructed in stages, and correct measurements of tilt and shift are the most important field observations which are required during the sinking of well. Because without the correct measurement of tilt and shift, you really will not be able to get to know that whether it is going beyond the permissible limit or whether it is within that. If it is within that, then there is no problem, but then it should not be more than the permissible limit. In case a well shows a tendency to tilt, dredging should be done from higher side. Higher side means it is going below the ground surface. So if you see the cross section in the vertical direction, then you will see that the 2 well standing you can see. So while you go for dredging, it can happen that one side if the tilting and shifting is taking place, so when the tilting shifts place, so one side can move more in the vertical direction and one can move lesser. So which moves in the the side which moves more in the vertical direction, that is called as the lower side, and which moves lesser is known as the higher side. In case this does not bring about any improvement, that is dredging, more dredging towards higher side, in case it does not bring any improvement, the sinking should be suspended and necessary measures to rectify tilts and shifts should be taken before resuming the sinking. So at any stage when you are seeing that during the sinking process that the tilts and shifts are becoming more, then you should stop sinking right at that particular stage, and first you should try to rectify that tilt and shift, and then only go for further sinking of well. Different methods are available to rectify tilts and shifts. One is controlled dredging. In this one, the dredging is done more on the higher side. This method is effective if the initial stages of sinking, but as the sinking progresses, regulation of grabbing becomes more difficult. So if in the initial stage of sinking only you are observing the tilts, then you can adopt this particular method, that is controlled dredging, to rectify tilts and shifts. But if you are as the sinking process is progressing, that is if the in the later stage of the sinking, if you are observing, this becomes it is not more useful, or it becomes difficult to use this kind of this method to rectify tilts and shifts. You can see here in this particular figure that here the dredging without hooking is going on, wherever here in this case the dredging with hooking is going on. So you can see here that platform to hold this particular line is there is a hook and a rope has been tied to it, and it is the loading. So this helps in this is a sort of controlled dredging, which at the initial stage of sinking is quite useful. Then the second method is eccentric loading. Cartilage is normally required to accelerate the process of well sinking. To provide greater sinking effort on the higher side of well, eccentric loading is provided through suitable platform. So, you will see here that if this is the higher side, so more of the cartilage is put here, right, so that the sinking becomes uniform, or the tilts and shifts, they can be rectified. Here it is, these are the two RS joist bracket which are properly welded and embedded into the well stenning and grouted. Here is this is the hole in stenning, and a flexible steel wire rope is coming in this particular hole. Here you can see that the cartilage is being provided. Cartilage is provided over here also, but towards the higher side, if you are observing any tilt and shift at any stage, so towards the higher side this cartilage is provided. So, this is what is your eccentric loading. Then the third one is pulling the well. So, pulling the well on the higher side is also effective in rectifying tilt. The pull can be applied by winding a steel wire rope round the well and tying it to a tackle anchor. To avoid damage to the well stenning, wooden sleepers should be used during pulling. You can see here in this figure that it is the higher side and this is the lower side. So, as I told you that pulling of the well on the higher side. So, here if you start pulling it from this particular at this particular side, that this is higher side, this helps in rectifying tilting and shifting. You can see here that various vertical sleepers, they are tightened with steel rope which is all around the stenning, and this is the steel rope and a pull is applied. You can see here this is the higher side and the pull is applied on the higher side. So, once the pull is applied, it this particular well stenning will have the tendency to move in this particular direction, and which will have the tendency to rectify this tilt which has been occurred in this particular direction. It should have gone vertically in this direction. So, you have to provide a pull here in this direction so that it can resume this vertical position. That means that it can rectify the tilt and the shift if it has occurred at any stage. The fourth one is pushing the well. Push to the well can be applied on the lower side of the well to rectify the tilt. This push can be applied by strutting the well against a dead man or against a vertically sunk well through a hydraulic jack. Let us see with the help of this particular figure. You can see this is the lower side and this is higher side. It is two rows of wooden pulleys, they are being installed here. This is strutting sleeper, this one, and this is sail sleepers fixed on surface of well with wire ropes wound round the well. So, this pulling is applied on the lower side. So, when the pull is applied, it will have the tendency to rectify the tilt and the shift if it has occurred at that particular stage. Here it has been shown that with the help of wooden pulleys this pull is being applied. However, if you have any vertically sunk well in the nearby area, then with the help of this jack you can apply that pull to the tilted one. So, you can see here two wells are there, one is vertically sunk well and another one is tilted well. So, with the help of a jack over here the pull can be provided. So, two ways are there. Then water jetting and or digging pit on the higher side. So, water jets are useful in sinking of well because of jetting, friction is reduced and thus rectification of tilt takes place. Excavation of pit on higher side is also useful in reducing the friction on higher side. We will see with the help of this particular figure that here it is the lower side, this is the higher side. You can see it is written here that higher side of the well, this has got tilted and this is what is your tilted side. So here you can dug a pit and fill it with water. This will reduce the friction over here and will try to rectify the tilt. So we have seen different measures to rectify the tilt and shift if it comes during the process of sinking. Now another one is that providing obstacles below cutting edge. Temporary obstacles in the form of wooden sleepers, sandbags or suitable hooks placed below the cutting edge on the lower side of well, they are useful in avoiding further tilt of well, while other measures to rectify tilt are being adopted. So previously we discussed the methods to rectify the tilt, but this particular this particular method, that is providing obstacles below cutting edge, will reduce the or will stop the further occurrence of tilt and shift. How it is done, you can see here with the help of this particular figure that here the hooking has been done, hook has been formed and over a pulley with the help of a steel wire rope. Although you are using the different methods which we have just now discussed regarding rectifying the tilts and shift, but additionally this obstacle below the lower side, you can see here that this is lower side, this is higher side. So here a hook has been formed and it is providing obstacle. So likewise here, and then if you are using sleeper pieces, so if you just provide the sleeper piece at the lower side of the well and put a obstacle, this will also help in further tilting and shifting of the well. So we have seen various methods related to the rectification of tilt and shift. Before that we took the various steps to be followed while you go for the elastic theory method as per IRC recommendations, and then we saw that with the help of an example that how different conditions which are recommended by IRC and IS codes can be satisfied when you do any numerical problem or when you deal with any practical problem related to the stability analysis of well foundation. So in this chapter of well foundation we saw various aspects related to well foundation, that it is a type of deep foundation and then circular, oblong, different shapes it can be provided. We have seen various advantages and disadvantages of different shapes. Then we saw that how you can find out allowable bearing pressure of well foundation, and then we saw that what all are the various forces which act on well foundation, what are the combination of these forces to be considered while going for stability analysis. Then I have discussed with you that the Terzaghis analysis to see the stability of well foundation. Further we discuss the elastic theory method of IRC with the help of example of these two, and then we saw various aspects related to construction and sinking of well foundation. And in that one we saw that the most important thing is that the tilting and the shifting of the well foundation should not be there during the construction and sinking process of well foundation, and we saw different methods to rectify the tilt and shift. And then we saw that providing the obstacle at lower side it reduces the further tilting and shifting of well. However, the other methods of rectifying tilting and shifting are to be adopted simultaneously. Thank you.